Alright guys, so today we are going to talk about adding rational expressions. Okay, so it's a little bit different. There's a couple extra steps than the multiplying and dividing rational expressions. Alright, and how I'm going to get us to remember that is we're going to flash back to some rational fractions. And a rational fraction is just a fraction. Okay, so let's first talk about what you used to do with those. Okay, so say you had 1/3 plus 3/4. Well, obviously, you remember you cannot add two fractions unless they have a common denominator. So 3 can't go into 4 and 4 can't go into 3. So you find the next best thing that they can go into. And they both can go into 12, so you have to make them look like 12, right? So you have to multiply this. 3 times what gives you 12? Well, 4. So we're going to multiply this by 4 over 4. And that gives me 4 over 12. Then 4 times what gives you 12? Well, 3. So we have to multiply this side by 3 over 3, which is going to be 9 over 12. And then once they have that common denominator, then we can add them together, right? So then 4 plus 9 is going to be 13 over 12, which would be your answer. Okay? Now, sometimes, so say you have 2 over 9 plus 1/3. Now, 9 can't go into 3, but 3 can go into 9, so we can make 3 look like 9. So we can actually leave 2/9 alone. And I know that 3 times 3 gives me 9. So that's going to be 3 over 9. Now they have a common denominator, and I have 5 over 9. So sometimes you don't have to change both sides. You just have to change one side, okay? So really you're just multiplying it by a piece that it's missing to make it look like each other, okay? One more example of this is sometimes you have your whole numbers. Say you have 3 plus 2 over 4. Now, we know to make a whole number a fraction, we put it over 1, okay? 4 can't go into 1, but 1 can go into 4. So 1 times what gives you 4? Well, 4. So we're going to say 4 over 4. And we're going to get 12 over 4 plus 2 over 4. And that gives me, I don't know why I did that. That gives me 14 over 4. Okay? And all of these can be reduced down. And with the rational expressions, we will reduce them down, which is just canceling out factors is all you do when you reduce fractions. Okay? Alright, so I have the steps written up here. So we have steps to adding rational expressions. So that first step has not changed this whole unit. That first step is to factor completely. Don't forget your GCF. And we're going to factor everything completely. Because you don't know what it's missing unless you have factored the top and the bottom. Okay? So, next, you get a common denominator. Exactly what we did up there. We're just multiplying each side by what the other denominator is missing. Okay? And then you cancel out your like factors. Now we're going to rewrite the new expression. Okay? So, now let's start simplifying rational expressions. Alright, so let's start with example 1. Okay? So example 1. Negative 7x plus 4 over 3x plus 5 plus negative 8x minus 3 over 3x plus 5. Now, factor first, okay? There's nothing to factor. 7 and 4 don't have a common factor. 3 and 5 don't have a common factor. 8 and 3 don't have a common factor. 3 and 5 don't have a common factor. All right, so we skip step 1. Step 2 is to get common denominators. Well, these already have common denominators, so we don't have to do anything. And sometimes you have them like that. Okay, I've seen them on tests. And kids are like, what do I do? What do I do? So I make sure I go over one. If they have a common denominator, it's just that simple. You just combine the top. So I'm going to combine the top. We're going to make it one big fraction. 7x plus 4 The plus and minus is just going to be minus 8x minus 3 all over their common denominator of 3x plus 5. After that, you clean up your like terms. I've got a negative 7x and negative 8x. That's going to give me negative 15x. Then I have positive 4 and a negative 3. That's going to give me a plus 1 over 3x plus 5. Now, when you get here, sometimes you can simplify it even more because the instructions say to simplify. That means lowest terms. Well, 15 and 1, there's no common factors. So this is as simple as it goes, and that's your answer. Okay? All right, next. Number 2 is going to be 3 over x plus 1 plus 4 over x minus 1. All right, so again, nothing to factor, okay? They do not have common denominators, so we need to multiply them by what they're missing, okay? So they can't be factored, all right? So x plus 1 and x minus 1, a lot of kids are like, oh, they both have an x, so let's multiply this by a positive 1, let's multiply this by a negative 1. No, this is together. X plus 1 is not the same thing as x minus 1. Yes, they have an x in common, but it's not the same thing. That would have been, it would have looked like this if you do that. This is missing an x. This you would multiply by an x on both sides, and then it would be x squared. But down there, that's not. This is a term, okay? I mean, it's a factor. So I need to multiply this side. It's missing the x plus 1. This side is missing the x minus 1. Okay? We got to distribute the 3. So I get 3x minus 3 over x plus 1. Distribute the 4, and I get 4x plus 4 over x minus 1. You have to distribute that 4, okay? Everybody gets it. Now, I'm sorry, they're common. Sorry. We're multiplying the top and the bottom by that. That is x plus 1, x minus 1, x minus 1, x plus 1. Now they have a common denominator, like up here. We can smush that top. So I'm going to say 3x minus 3 plus 4x plus 4 all over their common denominator of x plus 1, x minus 1. Clean it up. 3x and 4x is 7x. Negative 3 and positive 4 is going to be plus 1 all over their common denominator of x plus 1, x minus 1. Now, sometimes they full out the denominator back to standard form. And so if you did the box method, I'm not going to do it because we've been doing it so much. We should know to do it. So it's going to be x squared minus 1. Maybe I do need to do the box method. Okay. So, but either answer is the same thing. It just depends on if it's multiple choice. You got to fill it out, or if the instructions say make sure the denominator's in standard form. Okay? So it's all about your instructions, but I want to make sure you know and can recognize both types. Okay? All right. So, number 3. Number 3 is going to be 2x over x plus 3 plus 4x over x minus 1, x plus 3. Alright, so, I mean, you could factor that 4 is 2 times 2, but really you're mainly concerned with the denominator factoring right now, okay? So, this one, they both have an x plus... They both have an x plus 3 in common, don't they? Okay? So it's really about multiplying by what you're missing. Well, this side's not missing anything, but this side's missing an x minus 1, right? The left-hand side. So I'm going to multiply this left-hand side by x minus 1 over x minus 1. Okay? Distribute. 2x times x is 2x squared. 2x times negative 1 is negative 2x. All over x minus 1 times x plus 3. We didn't do anything to the second fraction, so we're going to leave it alone, or a rational expression, whatever you want to call it. Now that they have a common denominator, we can make it one fraction. We've got 2x squared minus 2x plus 4x, all over their common denominator of x minus 1, x plus 3. Okay? Now, I can clean it up. I got a negative, why does it do that? I got a negative 2x and a positive 4x. So I have 2x squared plus 2x all over x minus 1, x plus 3. Now, up top, you can pull out because you want to make sure it's in lowest form. So what if something else can cancel out again? So the top, you can pull out a 2x. And get x plus 1. But you got an x minus 1, so you can't cancel anything out. So it is in simplest form. Okay, so either answer is your answer. Okay? See, with adding and subtracting, it's just like so many steps because it's like you factor, you reduce, then you combine, then you factor, reduce again. All right, so it's just a little tedious. All right, so number 4 is going to be 2x over x plus 3. Sorry, that's wrong one. So this one is going to be 5y plus 2 over y squared plus 2x minus 4 over 4xy. So really, now that I'm like teaching and thinking about it, the denominator is really the main thing you want factored out so you can feel what it's missing. Okay, you really don't want to mess with the top as much because you're not going to cancel anything out. I mean, you can, but I just get common denominators and then I combine and then I just wait to simplify at the end. So you're only simplifying once, okay? But like I said, you know, there's so many different ways. Now, if you look, it's got an x, it's got an x, it's got a y, and it's got a y, but it's missing the y squared. This is missing the y squared, and then this is missing the 4. Okay, so you're really just multiplying by what it's missing. So this side is missing that 4, and this side, to get that to be a y squared, it's missing 1y. So we're going to distribute the 4. We're going to get 20y. I'm going to go ahead and make it one big fraction, okay? So we can start like getting rid of steps sometimes. So that's me plus 8 plus distribute the y, 2xy minus 4y, all over where our common denominator is every part. Well, every part is 4. They both have an x, and then it's a y squared. Okay? Clean it up. I can combine the 20y and the negative 4y, and I get 16y plus 2xy plus 8 over 4xy squared. Now, so remember when I tell you you have terms, every term has to have something in common before you can reduce it down. Well, not all of them have a variable, but if you look at the coefficients, what are they all divisible by? They're all divisible by 2, aren't they? So I can divide every number by 2, and my final answer will be 8y plus xy plus 4 over 2xy squared. And that would be your answer in simplest form. Okay? All right. Next one is number 5. Okay. Number 5 is going to be 3 over 7x squared times y plus 4 over 21xy squared. So again, what is each denominator missing? Well, this is a 7 and a 21. I can make 7 look like 21, right? I can multiply this by 3. So that takes care of the coefficient. Now they both have x's, but this has an x squared and this is just an x. So to make this x look like an x squared, I need to multiply it by an x. This one has a y, but this is a y squared, so this is missing one x. So we're going to multiply that by 3y. Okay? So when I distribute, I get 9y plus 4x over, well, you're making your common denominator. What were you making your denominator look like? Well, I was making it look like, I had to make that 7 look like a 21. I had to make this x look like an x squared. And I had to make this y look like a y squared. Now, 9, 4, and 21, they do not have a number in common. They do not all have y's. They do not all have x's. So guess what, guys? That is your answer. Okay? All right. Number 5. Oh, no, that was number 5. My bad. Number 6 is going to be negative 3x over x squared minus 9 plus 4 over 2x minus 6. So now we're getting into where we have to factor that denominator before we start seeing what it's missing. Okay? So let's factor. This is a difference of squares. So the square root of 9 is plus or minus 3. So we have negative 3x over x minus 3 and x plus 3 plus the 2 and the 6 have a 2 in common, so I can pull a 2 out. So what they have in common, I highlight what they have in common, and what I don't highlight is what the other side is missing. So they have an x minus 3 in common. So that means that this left-hand side is missing this 2, and this right-hand side is missing that x plus 3. Okay? So then we multiply. I've got negative 6x, distribute the 4, and I get 4x plus 12 all over, well, what is their common denominator? You got the 2, and then the x minus 3, and the x plus 3. Now, I can clean up, and I can say 6x plus negative 6x plus 4x, and get negative 2x plus 12 over 2 times x minus 3, x plus 3. Well, do these coefficients all have something in common? They do. I can divide every one of those by 2 and get negative x plus 6 over x minus 3, x plus 3. And then if you want it in standard form, you could have x squared minus 9. So one of these two answers will be your answer. Okay? All right. So number 7. Number 7 is going to be, let's see. Here, sorry, I lost my place on my paper. X over x minus 1 plus 2x minus 1 over x squared minus 3x plus 2. Now, this denominator is factored. The left-hand side is factored. But the right-hand side can be factored. Now, you can use Desmos. You can use whatever you're using, okay? I'm just going to factor it in my head. Because a is 1, I feel like it's pretty easy to factor in your head. And it's going to be x plus 1 or minus 1. Look at me. I talk about it and then I mess up. Alright, there you go. Now, they have in common an x. I can't stand that. They have in common an x minus 1, right? So the left-hand side is missing that x minus 2. But is the right-hand side missing anything? No. So we're going to distribute that x, and we're going to get x squared minus 2x plus 2x minus 1 all over, what is their common denominator? X minus 1 and x minus 2. Okay? clean it up. But what happens to this x, this to negative 2x and positive 2x? They cancel out. So you're left with x squared minus 1 over x minus 1, x minus 2. Now, this, remember how I told you you can factor again and cancel out again? Well, here you go. X squared minus 1, that's a difference of squares. So the square root of 1 is plus 1 and minus 1. And then looky there. I can cancel out the x minus 1's, can I? So my final answer is x plus 1 over x minus 2. So always see if you can factor, because I don't know if, I know study island is multiple choice, so it would help you out. But then when you get to delta math, you got to make sure you're checking that, okay, so you don't get it wrong. All right. All right, so number 8. Number 8 is going to be, here we go. Number 8 is going to be 7x plus 5 over x plus 2 plus 3x plus 2 over x plus 4. So the denominator is already factored for you. And this one's pretty cut and dry of what it's missing. The left-hand side's missing x plus 4. The right-hand side's missing x plus 2. Please, please, dear God, do not multiply the left-hand side by 2 and get x plus 4. Okay? I know y'all don't listen to me when I give you these warnings, but that is a factor. It's like best friends. They're together. If that right-hand side doesn't have an x plus 2, it's not the same. The left-hand side does not have an x plus 4. Okay? If it is in the plus or minus form of like x plus something, x minus something, that is together. Okay? So, sorry, soapbox for a minute. You know how I am. So I multiply the left-hand side by x plus 4. And I multiply the right-hand side by x plus 2. Now, this one, it's not as simple as distributing, okay? You actually have to do the box method, okay? So I'm going to have to box in x plus 4 and 7x plus 5, okay? So that left-hand side is going to turn into 7x squared plus 33x plus 20. Make sure I'm right on that one. Yeah. Then left, right-hand side, we're going to box it in. And get plus 3x squared plus 8x plus 4. Okay. All over, well, what's my common denominator? X plus 2, x plus 4. Okay. Now, I can obviously clean up that the numerator. 7x squared and 3x squared is going to give me, let's put this in a little. So I've got 10x squared, and then I can combine, keep it in standard form, so go to your linear term. Well, that's 8x and 33x. So 33 plus 8 is going to give me 41x. Then I have your linear term, which is going to be your 20 and your 4, which is going to be plus 24. All over x plus 2, x plus 4. Now, check it, because you can't factor out a GCF. So let's check this, okay, to see if it can be factored. A is not one, so I would actually go to Desmos and see if we can factor it, okay? So let's go to Desmos. Let's pull it up, pull Desmos up. And so we're going to see if it crosses the x-axis at nice pretty factors, okay? So we've got 10x squared plus 41x plus 24. Well, let's look. That's not pretty. That's not pretty. So you would have to, if you were solving this, you have to do the quadratic formula. So therefore, that is it, and that is your final answer. I know it ain't pretty looking, but it's your final answer. Now you could full out the denominator and put it in standard form also, but that's it. Okay. So number 9. Let's see. Number 9 is going to be this one. All right, so in the beginning, we did a fraction review. And remember when it had that whole number right there? We put 1 on the denominator because it's how you make a whole number a fraction. Same thing with a rational expression. Just put it over 1, okay? So I'm just going to put this over 1, okay? Now, left-hand side's missing x minus 1. Do I need to multiply the right-hand side by 1? No. I mean, you can if it makes you feel better. So I'm going to multiply this left-hand side by x minus 6. We're going to have to distribute that 3 and get 3x minus 18. Smush it with the other top because we don't have to do anything to it because it already has the common denominator. And the common denominator is x minus 6. So let's clean the top up. I've got a 3. I tell you, technology, so fickle. 3x plus 3x is going to give you 6x. All right. Then, sorry, laptop's about to die. Then I can combine the negative 18 and the 7. So negative 18 plus positive is going to give me negative 11. And then I have it over x minus 6. Well, 6 and 11 have nothing in common. So that is your answer. Let's see if I can move it back up here. Since it's just to save some space. Ooh. There we go. All right. Okay. Calm down, computer. So that is your final answer because you can't simplify it anymore. Okay? All right. So that one was pretty. It was simple as one line. Okay. So let's do number 10. Number 10 is going to be, here we go, 1 over x minus 6 plus 2x. Again, just like a number, if you want to make it a whole number, all you have to do is just put it over 1. Okay? So when I put 2x over 1, it's now a rational expression. Okay? So the left-hand side's missing nothing. The right-hand side, though, is missing that x minus 6. So I'm going to leave that 1 alone. Okay? Plus, distribute the 2x and get 2x squared minus 12x all over x minus 6. No, you can't combine anything on top, but let's put it in standard form, okay? So it's 2x squared minus 12x plus 1 all over x minus 6. All right, so let's see if we can factor that. So it's going to be 2x squared minus 12x plus 1. I don't know what I just did, but whatever. Plus 1. So is that right? Let's double check. Negative 2x squared minus 12x. Okay. So is that one pretty? No. So it cannot be factored anymore. So once in standard form, that is your answer. Okay? All right. Number 11 is next. Well, let's do this. Let's do that. All right. Number 11. Let's go to the next page. So number 11 is going to be 3x plus 1 over x. I like this x minus 6 denominator, don't I? I got these problems from somewhere, and apparently I did a lot of x minus 6 with these whole number or the whole rationals. So, all right. I think we just got this one and one more left. Yep. All right. So, again, put it over 1, and that makes it a fraction so you can get your common denominators. The left-hand side is good, so we're just going to bring it over. But I'm going to multiply this right-hand side by x minus 6. Do your box method. And you get 2x squared. Let's see. 2x plus 5, negative 7x. Don't judge, I used my calculator. Minus 30 over your common denominator of x minus 6. Clean that numerator up by standard form. The squared term has nothing in common, so we're just going to bring it down as 2x squared. All right. That over here so I don't get confused. Now, I do have two linear terms. I've got a 3x. I just don't understand. We got a 3x and a negative 7x. So that's going to, I just can't use my brain today. I'm struggling, guys. Struggle. I need my classroom back. Minus 4x. And then the constants have something in common. And it's a 1 and a negative 30. And that's going to be a negative 29. Well, 29 is prime, right? So, yeah, 29 is prime, so I can't factor that. So that is your answer. All right, last one. Number 12 is going to be, it's kind of a special one that you are going to probably see again. I know it's on your study island, but I know it's very common for teachers to use this, okay? So, really, the denominators look different, but let's rewrite that left-hand side. And we're going to have negative x, like putting it in standard form. Okay? Now, remember when I told you when your leading coefficient has a negative, factor it out. Okay? So that x is negative. Let's factor that negative out, that negative 1. Okay, so I'm going to factor a negative 1 out. When I factor a negative 1 out, that literally just changes the signs, right? And that's what a negative 1 does, is just changes the signs. And it's going to be x minus 5 plus 3 over x minus 5. Now, that negative 1 is really just a negative, correct? Just like a 1 is just a positive. And when you have a negative on the denominator or the numerator, you can actually move it to the top or move it to the bottom. Okay, that negative is just for the whole expression. So these denominators look exactly alike except for that negative. Well, that negative can be moved to that 5, and I can have a negative 5 over x minus 5 plus 3x over x minus 5. Now, side note. So, I know you've seen it before, like when you're reducing stuff and you get a negative 4 on the bottom, you can just write that as negative 3/4. I've seen you guys do that. Or you can write it as negative 3 over 4. A negative can go anywhere as long as it goes to everybody when you go anywhere. So, like if you have a 2x plus 5 over a negative 3, sorry, let's get rid of that negative. A 2x plus 5 over a negative 3. Say you don't want your denominator to be negative. You could write it as negative 2x minus 5 over 3. And vice versa. Okay? So that negative can be moved. It just needs to be, if it moves to the top, it needs to be moved to everybody. Alright? So, that's my side note. So now they have common denominators, don't they? And I can just smush the top and get negative 5 plus 3x over x minus 5. And that's your answer. Okay? Alright. So that's it for today's lesson. Okay? Hop on over to Canvas to see what you have to do. I believe it's a study island. Alright? But if you need any help, email me, questions, whatever. Alright, guys? I hope you have a good day.